Hi, this is Alex from devstories.eu. Apache Cassandra with Python, episode 3 of 12. In a relational database, you build your tables first, define your relationships, and then write your queries. In Cassandra, if you do not know your exact queries before you start, your database will fail. This is the core principle of query-driven data modeling. Many developers come to Cassandra with strong relational habits. You naturally look for ways to normalize your data, set up foreign keys, and avoid duplication. You need to drop that mindset entirely. Cassandra does not support joins. If you try to normalize your data across multiple tables, you will end up performing joins in your application code, which destroys the performance benefits you chose Cassandra for in the first place. Cassandra requires query-driven data modeling. You start by mapping the exact questions your application needs to ask the database. In this model, one query typically equals one table. If you need to access the same data in 3 different ways, you create 3 different tables holding the same data. This brings us to denormalization. Duplicating data is not a mistake here. It is the fundamental strategy. Disk space is cheap, but distributed reads across a network are expensive. By writing data together in the exact shape of your read query, Cassandra can retrieve it in a single operation without searching the entire cluster. To make this work, you have to understand the primary key. It is not just a unique identifier. It controls exactly where and how your data is stored on disk. The primary key has 2 distinct parts, the partition key and the clustering key. The partition key dictates which physical node in your cluster holds the data. All rows sharing the same partition key are stored together on the same node. The clustering key determines the sorting order of those rows on the disk within that specific partition. Take the magazine publication scenario from the documentation. Suppose your application needs to fetch all magazines released by a specific publisher. Your partition key must be the publisher name. When the query arrives, Cassandra hashes the publisher name, identifies the exact node holding that publisher's data, and goes straight to it. To organize the results naturally, you might use the publication date as your clustering key. Now, not only are all magazines for that publisher grouped on one node, but they are physically stored in chronological order. The database just streams the pre-sorted data back. Here's the key insight. You are trading write complexity for massive read speed. You write the same data to multiple tables to satisfy different application views, but when a user asks for that data, it returns in milliseconds because the database does 0 computation to assemble it. Thanks for listening. Take care, everyone.